After a lot of research and a lot of saving, I got this Desktop CNC machine. Small enough to keep on a desk in the garage, but big enough to serve all my board game prototyping needs. And it can also do something else that I've been wanting to do forever. Make my own PCBs. Let me show you how. First step, design the PCB. I open Fritzing and put everything into place in the breadboard view. I usually do this at the same time or shortly after I assemble it all on a real breadboard, where I can test if it all works. But today we're building something so simple we can't really go wrong. I want to build a tiny PCB just big enough to hold an ESP32C3 Super Mini and a DHT11 temperature sensor. The goal is to make a bunch, flash them with ESPHome and then turn them into little sensors that I can spread all around the house so I can get temperature readings from each room in Home Assistant. First we need the ESP32C3 Super Mini. This component wasn't included with Fritzing, but someone created it and shared it. Thanks. Furthermore, we need some pin headers. These are under the core components and we can configure them to our exact needs. Female, size 1mm is perfect, and we need 3. Now I connect ground to the ground rail of the breadboard and 3.3 volt to the power rail. Always a good idea to set wire colors to something sensible. Then I connect power and ground to the headers. And the data pin I connect to whichever pin I want to use on the microcontroller. That's all we need here. Now let's route this in the PCB view. I rotate everything the way I want it. I rotate the pin headers to see which way around works best with the connections. Then I shrink the PCB to size. And then I grab the connections to actually get them routed. I want to create the most simplistic single layer PCB, so I make sure nothing crosses anywhere. It's quite easy in this case, but with more complex projects it can become quite the interesting challenge. I could of course make a double-sided PCB, but single-sided is the quickest and easiest. Okay, looks nice enough. Now I make sure everything is on the top layer. You can tell by the slightly different color. Then I save the project and I export the PCB for production as extended Gerber files. And that's all we need to do in Fritzing. Next, we need to set up the individual steps of how we would like to machine the PCB. I'll do this in Makera CAM. I create a new 3-axis project. I edit the stock to make sure it's set to a PCB and has the correct dimensions, 150 by 100 mm, 1.5 mm thick. Then I import the files I exported from Fritzing via the Import PCB menu item. It spit out a whole bunch of files. The first one I need is Contour. This consists of 2 borders on one layer. I need to split these into separate layers because I want to use one as the contour that will be cut out in the end and one as an outer border for the pocket operation that removes all the copper we don't need. So I select the outer one, cut it, make sure this empty layer 1 that came with the new project is the active layer and paste into it. For some reason Makera CAM insists on pasting at an offset of 5 mm, so I have to press M for move and move it back to where it was manually. I rename the layers to something sensible. Next I import the copper top file, which comes with 2 layers. One has the connections and the pads, one has just the pads. This second layer is useful if you paint your boards, then you can use it to remove paint from the pads, but we won't do that, so we can simply delete it. We don't need the copper bottom file because there's nothing on it. The only thing we still need is the text file that holds all the drill positions. Great. Now let's select everything and move it away from the corner by just a bit, like 3 mm. And now comes the interesting part. We need to create the actual tool paths for the machining process. First, we remove all the copper outside of the routed connection paths. We can do this with a 2D pocket operation. I set the end depth to 0.1 millimeters. That's how deep the pocket will be. Not deep, just enough to get rid of the copper. The tool we want to use for this is a 0.2 millimeters 30-degree metal engraving bit. Since we've set our stock to PCB, it pre-selects the settings for PCB here. Very convenient. It fills in the correct values for the PCB. Nice. I switched the path strategy to parallel, but offset would work just as well. This only defines how the tool travels as it clears away the copper. The rest is all fine. Now before I can calculate the path, I need to select what it should calculate it from. So I select the inner contour and the copper top layers. And have a look. This is what a path looks like. Next we drill the holes. I set up a new 2D drilling operation. We want to drill all the way through, so we need to set the end depth to more than the height of the stock. 3 millimeters more is what the manual suggested, so I'm setting it to 1.8 millimeters. This will cut into the MDF spoil board underneath, but that's fine, that's what it's for. As the tool, I choose a 1mm by 10mm drill bit. 1mm corresponds to the size of the headers we selected in Fritzing, and it's the standard size that works for most things you'd stick in a PCB. Again, the settings for PCB are pre-selected, great. I select the graphics from the drill holes layer and press calculate. Great, now we have the holes set up. Now the only thing left is cutting out the board. I do this with a 2D contour operation. End depth again 0.3 millimeters deeper than the height of the stock, so 1.8 millimeters. As the tool, we're gonna choose a corn bit. 0.8 millimeters should be fine. Doesn't really matter. I make sure it cuts on the outside of our path. Direction doesn't matter much in this case. I select the graphics on the contour layer. And one last step that is very important, tabs. To make sure the finished piece doesn't fly off or damage something when it gets cut free from the stock. So we add tabs to hold it in place. You could also use double-sided tape underneath, but this is easy enough. I just add 3, exit back out of the add mode and calculate the path. See those triangle shapes it leaves out? We'll cut these later with a tiny saw. Done. Now all we need to do is export the paths. I check all the paths and export. This exported G-code file we will now upload to the CNC machine. I start the Carvera controller app, connect to the machine, and upload and select the file we just exported. This gives us a preview of the entire tool path. Now we get everything ready for machining. I add a little bit more offset from the corner just to be safe. I make sure scan margin is checked. This will cause the laser to travel once around the perimeter, so I can make sure we won't cut into any of the clamps. I activate auto leveling and configure it to something that makes sense. The machine will check each of these points and then take all unevenness into account when machining. And that's it. Let's go. I mount a single-sided PCB blank into the machine. I put in the probe tool and press the button to tell it to get started. And then I switch tools as required. And a few minutes later, the PCB is done. I cut off the tabs. The machine came with a little saw for exactly this purpose. And there it is, our little PCB. I solder on some headers. I adopt the thing into my ESPHome network, edit the YAML and install it wirelessly. And it works! I'm getting temperature and humidity readings. Very nice. Now, does it make a lot of sense to do a PCB for something this minimalistic? Probably not. You could do the same thing with 3 jumper cables. But I wanted to show you the process on a really simple project. If you're interested, I can do a video on my MQTT capable ESPHome controller for RGB LED strips. Let me know in the comments. Maybe subscribe if you want to see more CNC projects. Thanks for watching.